Alright guys, open up to problem 10-66. Salvador was studying microscopic pond animals in science class, and he read about amoebas that were 0.3 millimeters to 0.6 millimeters in length. And he saw that the euglenias were as small as 8.0 times 10 to the negative second millimeters. But he didn't know how big or small a measurement that was. He decided to try to figure out what the negative exponent could mean. Part A says, copy and complete Salvador's calculations at the right. Use the pattern of dividing by 10 to fill in the missing values. So we have 10 to the third is 1,000, 10 to the second is 100, and 10 to the first is 10. 10 to the 0 power is going to be 1. Actually, anything to the 0 power but 0 is going to be 1. So if I had 2 to the 0 power, that's going to be 1. 3 to the 0 power, that's also going to be 1. But if I had 0 to the 0 power, that's going to be 0. Okay, so the next one in the list was 10 to the negative first power. So anything to the negative power is going to be a decimal. So 10 to the negative first power is going to be 1/10, or 0.01, sorry, just 0.1. The next one was 10 to the negative second, and that is 1/100th, and 10 to the negative third, that's 1/1000th. Part B asks how 10 squared is related to 10 to the negative second power. 10 squared is 100, and 10 to the negative second is 1/100th. So what do you know about 100 and 1/100th? Well, you should know that they're inverses or reciprocals of each other. Part C says, what type of numbers did the negative exponents create? Did negative exponents create negative numbers? Negative exponents created decimals or fractions. Second part of the question asks, did they create negative numbers? Well, we started with positive bases, so our base was 10, and those were all positive tens, and we had negative exponents like -1, or -2, or -3, so think about it. Did we get any negative numbers? No, we just got fractions or decimals. We got positive numbers. They were just decimals or fractions. So we started with positive bases, and they did not create negative values. So let's look at 10-70. We have 6 to the third over 6 to the fifth, and we can use exponent rules to simplify this. So we can first expand it, and it would be 6 times 6 times 6 over 6 times 6 times 6 times 6 times 6. And we know we can make the giant 1, and we can cancel out 3 sets of 6's, and then we're left with no 6's on the top, so a 1, and on the bottom of the fraction we're left with 6 times 6, which would give us 36. Now, 70 asks us to show this in two ways. One, as a positive exponent, and as a negative exponent. So if that's 1 over 36, or 1 over 6 times 6, that would be 1 over 6 squared, or how could we show that as a negative exponent? It would be 6 to the negative second power. So then the shortcut with the exponents when you have a fraction would be just to take the exponents 3 and 5 and subtract them. 3 minus 5 gives you 2, so you would get 1 over 6 squared. And actually, in simplest terms, you would leave it as 1 over 36, because in simplest terms, we don't leave things with negative exponents. So here's part B. We have 3 squared over 3 to the 6th. So if we use the exponent shortcut, we would do 2 minus 6. We would have a 1 on the top of our fraction, and 2 minus 6 would give me 3 to the 4th power. So then if we would simplify that, we would get 3 times 3 times 3 times 3. What do you get? So you will get 1 over 81. And the question also wants you to show it as a negative exponent, so it would also be 3 to the negative 4th power. Here's part C, m to the 5th over m to the 6th. Try to simplify it on your own. You should have gotten 1 over m, or m to the negative 1st power. Let's do part D. B squared over b to the 5th. Hit pause and try it on your own. Hopefully you got 1 over b cubed equals also b to the negative 3rd power. Go ahead and try the rest of the questions on your own.